Unit 7, Day 2 notes. In Day 1, we looked at taking an equation of a graph and translating it by putting plus or minus inside with the x. That would be a horizontal translation, left or right. Then we did plus or minuses outside of the f of x, and that was going to be a vertical translation up and down. So we're going to do a little bit more transforming. Okay, it won't be all translations, but this will be some fun stuff. We get to manipulate our graphs a little bit more, a little mastery over these graphs and use them in different ways. Okay, so let's look at this first topic, transforming the graph of a function by reflecting it over an axis. Now, hopefully you remember what reflections are from back in your geometry days. It's just creating a mirror image, and that mirror happens to be here, one of the axes. It could be the x-axis or the y-axis. So if we reflect over the x-axis, okay, so here's an example. Here's the x-axis. And if I start with a point anywhere on the graph and I reflect it over the x, okay, it goes over the x and it would be up here somewhere. Okay, just remember this. If it's reflected over the x, then that means that the y has changed for that point. Okay, so check this out. If the negative is outside of the x, okay, notice that here's the parentheses. The negative is outside. If it's outside, it changes the sign, S-I-G-N, of the y coordinate. It changes the sign of y. A negative outside of the x changes the sign of y, which means that you will multiply your y coordinate by -1. Okay, there's a negative outside of f of x. Remember, f of x is just another way to say y. Okay, it's a more sophisticated way. Okay? We don't have to say y equals. We can say f of x equals. So instead of negative f of x, we're saying, okay, it's the opposite or a negative of y. So whatever your y coordinates are, we multiply them by -1. So for example, if we did this, and we had the point 2, 1, okay, 2, 1, if we have a negative outside of the f of x, we are going to change the sign of the y. So it's going to simply be 2, -1, because 1 was my y coordinate. I changed the sign of my y. Okay, so if we're going to reflect over the y-axis, if you jump over the y-axis, okay, so here's the y-axis. If I have a point on the y-axis that's going to go over the y-axis, we're going to change the sign of x. So how do we change the sign of something? We multiply the x coordinate by -1. That's all there is to it. You multiply the x by -1. So yes, all you're going to do is change the sign of x. How do you do it? Multiply x by -1. Well, if you have the point 2, 1, and you want to change the sign of the x, we are now going to have -2, 1. Okay, so let's look at these steps and then scoot down the page a little bit. So if we're going to reflect a graph, which is more than just one point, okay, it might be a line segment. Okay, it might be a V. Okay, it can be any type of a graph. But look what it says. Find the key coordinates. I like to say the critical points. So the critical points would be any endpoint. Okay, in this case, the V would have 3 endpoints. You'd have your vertex, and then you'd have these other 2 endpoints as well. So you're going to find the key coordinates, and then it says you're going to transform them using the reflection rules above. And you're just going to plot your points. Okay? That's all you got to do. So without any further ado, let's scoot down the page just a bit and see if we can do a couple of these examples. Okay, so we just scooted down a little bit here. Let's use these 3 steps to do these 2 questions. I think you'll find it pretty nice. Let's check it out. Okay, so example 1. Okay, so below is the graph of y equals f of x, right here. Graph y equals, and then we have a negative outside of the f of x. So step 1, find the key coordinates. Well, here I would say the key coordinates are the endpoints. And those endpoints are at 0, -4, and at 7, -4. Okay, 0, -4 is this one, 7, -4 is this one. All right, so we have our key coordinates. Done. Step 2, transform using the rules of the reflections above. Okay, now the rule of the reflection was if you have a negative outside of the f of x, okay, it's not in the parentheses. If it's outside the parentheses, we are going to change the sign of y. Okay, so all we're going to do is multiply these y coordinates by -1 and change their sign. That's it. So now we're going to plot the new points. So 0, -4 becomes 0, +4. So we're going to bring him or her up to 0, 4. And then 7, -4, we're going to change the sign of y, and it's going to become 7, +4. And then we'll connect the dots. So notice that what we did, here's the x and the x-axis. We reflected over the x-axis, as it said in the steps up above, okay? But what we did was we just said negative is outside of the parentheses, therefore it changes the sign of y. Done. That's all we do. Okay, let's look at the other question. Question number 2. Now we're going to have f of -x. So the negative is in with the x. Let's look at our steps. First, we're going to find the key points. I would say the key points are this endpoint, and we have a vertex where 2 sides meet, okay, a little corner. So where are these points? Well, this one here is at -4. This one here is at -4, 1. I'll just write that off to the side. -4, 1. This guy here is at 4, 5. And then this little guy over here is at 7, 2. Okay, so we've identified our key points. Cha-ching, good stuff. Next, we want to transform using the rules for the reflections. The rule is when the negative is inside with the x, we change the sign of x. So change sign of x. All we're going to do, change the sign of x. So let's look at this point right here. -4, 1. If we change the sign of the x, it becomes a +4, 1. So let's put this in green, make sure everyone can see it. Okay, so +4, 1 is right here. Okay, we have changed the sign of that x. Okay, +4, 5. We're changing the sign of x, so that would be -4, 5. So that would be right about here. Oh, a little off. That's a little better. Okay, so that point right there. And then finally we got 7, 2. Change the sign of the x, it's -7, 2. So -7 and up 2 is right there. Okay, we're going to connect the dots. Ching and cha-ching. So as you can see, as it says in the rules up above, we have reflected over the y-axis. Here's the y-axis, okay? This point reflected over to this point. Okay, this point reflected here, this point reflected here. Okay. So we have reflected over the y-axis by changing the sign of x. Okay? I wouldn't even concentrate on the whole reflecting over which axis. I would just say the negative is inside with x. We change the sign of x for each critical point or each key coordinate. All right, so hopefully that's good. Let's look at the next little piece we have here. Now, if anything is going to trick people in or just give people a tougher time in this section of Unit 7, it's probably going to be this part right here, when we are multiplying the x and the y by constants. Okay, so it's stretching and shrinking. Okay, vertical stretch and shrink. Vertical, we're talking about the y. So if we take a constant a, okay, a could be any number. It could be like y equals, let's see, the constant is 6. 6 f of x. Okay. Any number, a. No matter what that number is, right, we are going to multiply the y coordinate by that a. Okay, whatever that number is. That number could be 1/3. It could be 7. It could be 2. Okay? Whatever that number is, we're going to multiply the y coordinate by that coefficient, the number in front of the variables. Okay. So in this case, the number in front of parentheses, if you have parentheses there. So if your a happens to be bigger than 1, it's going to stretch it vertically, which means it's going to make it look skinnier. Okay. If a is between 0 and 1, then it's going to shrink it and it's going to make it look wider. Okay. So if we have y equals 3 times f of x, the 3 is outside of the parentheses. Okay, so the 3 is multiplied by y, okay, multiplying by y. So which of these two coordinates is your y coordinate? Well, obviously the 1 is. It goes x, y, 2, 1. So we're going to multiply the 1 by whatever that number out in front, the coefficient is. Okay, so 2 stays 2. 3 is multiplied by the y, so 3 times 1 is 3. So if you had the point 2, 1 in f of x, and you were supposed to graph 3 times f of x, then you are going to have the point 2, 3, because 1 times 3 is 3. Okay, that one seems pretty straightforward. Now, when the a, or the number, is inside the parentheses, okay, if it's inside the parentheses with the x, this one is where people sometimes get a little mixed up. Okay, let's say that we have, instead of y equals just f of x, it could be f of 6x, because up above we had y equals 6 f of x. Okay, so if the 6 or whatever number it is inside the parentheses with the x, it's going to affect the x. Okay, it's going to affect the x. But because it's inside with the x, if you remember in day 1 notes, when we had like x minus 3, that minus 3 went to the right, which on a number line is positive, or it increases. So minus 3 was the exact opposite of what you would have thought. If it had been plus 3, you would have said it goes to the left, and you think, but plus means positive, And it's the exact opposite of what I'm thinking for the number line. So when you're multiplying and dividing, it's the same thing. You are going to do the opposite of what you're thinking of. So whatever this a is, right? Whatever this a is, we are going to divide the x coordinates by a. Okay. So up above it was multiply for y, but for x, we're dividing. Right? So if a is bigger than 1, it's going to be a horizontal shrink, which is going to look like a vertical stretch. Okay? A horizontal shrink, it's like sucking your gut in. It makes you actually look like you're taller, okay, sort of skinnier. If a is between 0 and 1, then it's a horizontal stretch, makes it look wider. And if you're thinking, well, what if a is less than 0 on these here? When it says, well, a is greater than 0, less than 1. Okay, if a is less than 0, then there's a negative. And the negative is the reflecting that we already talked about. Okay, you don't have to worry about the negative. If a is less than 1, it's going to be a vertical shrink, right? If it's greater than 1, in this particular one here, you got a horizontal shrink, all right? So y equals f of 2 times x, this guy right here. Again, what does it look like it's saying in the parentheses? It looks like it's saying 2 times x. So guess what? We do the exact opposite. So the opposite of multiplying by 2 is dividing by 2. So we're going to take this x, we're going to divide it by 2, we're going to get 1. Okay? You don't change the y at all. The y stays the same. Okay? Now, what if that had been like a 1/3? If there were a 1/3 there, dividing by 1/3 is like multiplying by 3. Okay? Hopefully we'll find one of those down here in just a moment. Okay? So let's scoot down the page, and once again, same 3 steps. Step 1, find the key coordinates. So let's look at example 1. The key coordinates are the endpoints of my line segment. So we've got 0, 0. I'll just put them by color here, 0, 0. And then this guy over here is 4, 4. Okay, so let's look at what we're supposed to do to that. Okay, so we've identified the key coordinates. Great. Now I'm going to transform them using the rules for our well, it's not reflections here. It should be rules for our stretch and shrink. So you can actually change that, stretch, shrink above. Okay, so the rule here is, okay, it's y equals 2 times f of x. That 2 is outside of the parentheses, so it affects the y. Okay, and remember, when the y, plus is up, minus is down, times is times, divide is divide. Perfect. This is 2 times f of x. So I'm going to multiply by 2. Okay, and what am I going to multiply by 2? Well, we just said it's not inside the parentheses, so we're going to multiply the y by 2. You multiply 0 by 2, you still get 0. So you get 0, 0. Thrilling. Okay, multiply this y by 2, you get 4, 8. So let's go to 4, 8. And connect the dots. Plotted our new points. Cool. Okay, that's it for example 1. So it said times 2 outside of the parentheses. So it's the y times 2. All right. Now look at example 2. This is the one that will trick people in more ways than one. So here we go. Let's look. Step 1. Find the key coordinates. Right? There's a 0, 0. There's a 2, negative 4. And there's a 4, negative 2. Isn't that nifty? Cool. Step 2. Transform using the rules for reflection. All right. There's a 1/2 inside with the x. Right? So the rule says we're going to divide because it's in with the x. We're not going to multiply. We divide with the x. So dividing by 1/2. Dividing by 1/2. I don't like to divide by fractions. I like to famzo. Flip and multiply the second one. Okay, so if I have something divided by 1/2, 1/2 is the second one. So I'm not going to divide by 1/2. I am going to multiply by the flip or the reciprocal of 1/2, which is 2 over 1. Okay? So I am going to take that 1/2, which is in with the x, so I'm going to do this to x. And instead of saying I'm dividing by 1/2, I'm going to say I'm multiplying by 2. Okay? Pause it, rewind it, listen to me say that a few times if you need to. Okay? If it's a number that's inside with the x, that's being multiplied by the x, okay, that's 1/2 times x. Okay? The rule above says we're going to divide by that 1/2. I just don't like dividing by fractions. So we multiply by the reciprocal, also known as famzo. Flip and multiply that second one. So we're going to multiply the x coordinates by 2. So 0, 0, 0 times 2 is still 0, so we still get 0, 0. Multiply this x coordinate by 2, you get 4, negative 4. So let's go to 4, negative 4, which is right there. And then multiply this x coordinate by 2, you get 8, negative 2. So 8, negative 2. Okay. There you have it. You have multiplied by 2, which is the same as dividing by 1/2, every x coordinate. So if you really like to say I'm dividing by a fraction, okay, 0 divided by 1/2 is 0. 2 divided by 1/2 is 4, and 4 divided by 1/2 is 8. Okay, so if you like dividing by fractions, think of it that way. I like to say I'm not going to divide by 1/2. I'm going to multiply by the reciprocal. Okay. So let us scooch down and look at the next piece. So now we're going to put together multiple translations, and we need to know if I'm going to reflect, if I'm going to translate, if I'm going to shrink or stretch, if I'm going to do more than one of those things, what order do I do them in? Because if I shrink it and then reflect it, that might be a different result than if I reflect it then shrink it. Or if I say I'm going to translate it, then reflect it. That could be very different than if I reflect it then translate it. So here's the order that you are going to do your different transformations. So the first thing that you will look at is horizontal transformation. Okay, the horizontal translations. So if you have a plus or a minus in the parentheses, okay, in the parentheses. So remember, if it's plus C, you're going to go to the left. Okay? If it's minus C, you're going to go C units to the right. Okay? So for example, if I say I had 2, 1 in my original graph f of x, but I want to plot f of x minus 2. Well, I would go 2 to the right, right? So 2 to the right, right? Where, if I'm looking at 2, 1, 2 to the right would be 4, 1, okay? Rewind that if you need to remember that, because it says minus 2, 2 units to the right. 2, 1, 2 to the right will be 4, 1. Okay? Please notice that what we did first was what was in the parentheses. We're going to follow PEMDAS. Okay, we're going to follow PEMDAS. So there are no exponents. So PEMDAS, you can take the E out. But now the P is done, we're going to go the M and the D. Right? So multiplying and dividing. Well, what happens when we multiply or divide? Well, we just went over that. Okay, if there's an A outside, we multiply the Y coordinate by your A. So the Y coordinate is 1. If we're going to take 3 times f of x, we multiply the Y coordinate by 1. So it's 2, 3. If the f of x has A inside the parentheses, we're going to divide the x coordinate by A. So if it's f of 2 times x, right, f of 2 times x, we are going to divide x by 2. Well, 2 divided by 2 is 1, 1. Okay? We've done this very recently. So what did we do here? We multiplied. This was multiplied or division. Okay? So multiplying and dividing. So the M and D for PEMDAS, okay, applies to both of these. Okay. The M and D also applies to multiplying or dividing by -1. Okay. So we're still multiplying. So we took care of parentheses first. Okay. And this, I'm hoping this will make a lot more sense when we do the last couple of questions and we use this, right? So hold tight, hold tight. If this is a lot of words or a lot of chart, relax. It's not going to be that bad, I promise, right? So if we have a negative outside of the x, outside of the parentheses, we're multiplying the y coordinates by -1. This is just a review. So we would multiply the y coordinate 1 by -1. If the negative is inside with the x, we're going to multiply the x coordinates by -1, change the x sign. So change the sign of the x, so we get -2, 1. Right. So this is all multiplying and dividing. So we're still at M and D. So you take care of in the parentheses first. Okay, parentheses first. You take your multiplying and dividing numbers. Take your multiplying and dividing signs, where it's just the negatives or the positives. Okay, if it's positive, then you don't have to reflect anything. And then the very last thing in PEMDAS is adding and subtracting. Here's your P. Again, we don't have any exponents. M and D, and then A and S. So A and S, back to day 1 notes, vertical translation. Okay, you have plus or minus, but it's outside the parentheses. So if K is positive, so plus a positive number, we're going to add it to the Y coordinate and go up. If K is negative, we're going to subtract it from the Y coordinate and go down. So if you have f of x -4, you subtract 4 from your Y coordinate. Subtract 4 from 1, and you get 2, -3. This is a page that you're probably going to want to go back and replay and look at, little pieces of it, and listen to it again and again when you do your practices. And then if you have questions, come into a Zoom meeting. All right, so let's scoot down and finish this off. Okay, our last 2 examples. All right, so for part A, Okay, part A goes with this one right here. It says they've given you g of x. Okay, that's g of x. They've given you the graph. They want you to draw this. Instead of g of x, negative g of x plus 3. Okay, so what's going on with this thing? There's a couple of things that are different between this and that. One is there's a plus 3, and one is there's a negative outside. So we've got two different transformations. We just have to make sure that we do the right one first. So according to the PEMDAS says in the parentheses, in the grouping symbols first, we're going to do that first. Okay, so here we go. We're going to move everything plus 3 inside, so we're going to go left 3 units. Okay, that minus on the outside tells me that we are going to change the sign of y. Okay, it's a negative on the outside. So change sign of y coordinates. All right. So let's look at each of these 3 key coordinates, these key points, the critical points, I like to say. Right? Let's look at each of them. So let's start with this point right here. So this is the point -2, 4. Right? -2, 4 right here. And we want to move it left 3 units because we want to take what's in the parentheses, that plus 3, and we want to affect the graph with that first because of PEMDAS. In the parentheses, we're going to go left 3. So if I went 1, 2, 3 to the left, what am I doing? I'm subtracting 3 from my x coordinate, and that would bring me over here to -5, 4. Okay? But now we need to change the sign of the y. Okay? We need to change the sign of my y. So I've got my y coordinate is 4. So I'm going to change the sign to negative. So that means that original red dot that we have right there is going to go to -5, -4, which is right about there. So how did we get there? We went 3 to the left, and then we changed the sign of the y. Okay? 3 to the left, change the sign of the y. Let's do that with 0, 0. 0, 0. Let's go right here. Okay, so 0, 0. If we go left 3, 1, 2, 3, what are we doing? We are subtracting 3 from our x. So left 3 brings us to -3, 0. Okay? Now we need to change the sign of y, which is nice because changing the sign of 0 is not going to affect it. Okay? Changing the sign of 0 is going to still have 0. So -3, 0. Okay? So what happened? We went 3 units to the left, and then when you reflect over the axis that you're sitting on, you don't move. Okay? So we got 2 out of the 3 points. Let's get the last one. This third point is 4, 2. All right, so let's do the 2 things here. We're left 3. So if I go left 3, I'm going to subtract 3 from my x. Subtract 3 from 4, and you get 1. And now we're going to change the sign of y. Change the sign of y. y is 2, we go to -2. So 1, -2, right above there. So how did we do that? We went 3 units to the left, and then reflected over the x-axis by changing the sign of the y. That's what we did. All right, let's connect our dots, and you're done. Okay, you're done with part A. Okay, part B. Let's clean this up a little bit. Last one. Here we go. Let's do it. Part B. We've got f of x right here, that little v. And what's going to happen to f of x? Well, we're going to change it to f of 2x in parentheses minus 4. So again, I like to look at what these things say. So remember, the 2 is inside with the x. So I'm going to divide my x by 2. And there's a minus 4 on the outside, which means I'm going to go down 4. If it were minus 4 on the inside, okay, then it would be affecting the x like we did with the g of x. Okay, then minus 4 would go to the right. But it's minus 4 outside of the parentheses, so it's going to affect my y. Minus is going to go down. Cool. So let's look at how we're going to draw our new graph. Let's start with the first point. Let's start with this key point right here. -4, 0. -4, 0. Okay, now we need to do 2 things to each of those 3 critical or key points, the coordinates. But which one do we do first? Do we do the -4 first? Or do we do the dividing by 2 first? Okay, think of PEMDAS. Think of PEMDAS. So dividing D comes before the subtraction S in PEMDAS. So we're going to divide x by 2 first. So here's my x. Let's divide it by 2 first. -4 divided by 2 is -2. And then finally, we're going to go down 4. So if I go down 4 units, I mean, what does that mean? It means we're going to subtract 4 from my y. So let's do that. Subtract 4 from the 0, and you get -4. So -2, -4. All right, so -2, -4. Well, looky. It is pure coincidence, but and I'll use orange just to show up a little bit better. That point right there is where the green point went. So the green point went to the orange point. Okay, the fact that that happened to be part of the original graph doesn't matter. Okay, so now I'm going to take that -2, -4, around it there. All right, just to show that it was part of the original V. Okay, and let's do our transformations to that one. So -2, -4 is going to be our second key point or key coordinate pair that we want to use. So let's look at, in order, in the parentheses, we're going to divide x by 2 first. Okay, if we divide this x coordinate by 2, we get -1, -4. Then, second thing we want to do is go down 4 units. Okay, so down 4, indicates that the y is decreasing by 4. So if this y decreases by 4, we are going to be at -1, -8. Okay, so -1, 8. Take our last original point, key point from f of x, which is 0, 0, which hopefully will be just as easy as 0, 0 has been for the other graphs that we have. Okay, so we start with 0, 0. Okay, again, inside the parentheses, we are dividing our x's by 2. 0 is our x. Divide 0 by 2, and you get 0. So 0, 0 stays at 0, 0. Okay, and then finally, we want to go down 4. So down 4, we're going to subtract 4 from our y coordinate, our 0. And when we subtract 4 from 0, we get -4. So 0, -4 will be our last point in our f of 2x minus 4. We're going to connect the dots. Oops. There we go. Okay, so what did we do? We horizontally shrunk. Okay, we made it thinner, and we moved it down. And it makes sense. There's the horizontal shrink, and then there is the moving down 4. Okay, so that's what you're going to be doing in your ALEKS. I do believe that we have reached the end of our notes for today. We're getting pretty close to the end here, so stay with it, stay after it. I think this is one of the more challenging days of notes that we've had finally in Algebra 2, where we're breaking away from Algebra 1 and really doing stuff that's different. And I hope that you're enjoying the difference and the challenge a little bit. And again, go back, rewatch little pieces of the explanations. If you miss something, go back, play it again. Okay, so good luck with this. Let me know if you have any questions. Take care. Bye.